Hello, welcome back. Today we're going to go over an exercise where we're going to apply the mean value theorem for integrals to the function f of x equals 4 cosine x over the interval negative pi over 3 and pi over 3. But we want to make sure that the mean value theorem is applicable for this function on the given interval. All right, here's a statement of the mean value theorem for integrals. So if you start with a continuous function f on the closed interval a and b, then it's guaranteed that there exists a number c in between a and b such that the value of this integral, which is integral from a to b of f of x dx, is exactly equal to f evaluated at c times the difference between the end points. Well, speaking of f of c, that is just a fixed number once you know c. You may think b minus a to be the length of one side of the rectangle and f of c to be the length of the other side of rectangle. This looks like an area of a rectangle. So why don't we hit the road and solve this problem? Once we have the visual, you will have a better understanding of what mean value theorem means in terms of finding a definite integral. All right, here's the statement of the mean value theorem, copied. So all we're going to do is to evaluate the definite integral and try to come up with the c, but beforehand we have to make sure that the mean value theorem is applicable for this function on the given interval. Well, we have 4 cosine x, and we know that cosine x is continuous for all x on the real line, and in particular, it should be continuous on the interval negative pi over 3 and pi over 3. So we should be safe to apply the mean value theorem for this function. So why don't we apply it? So here the lower limit would be minus pi over 3. Upper limit is going to be pi over 3. And f is 4 times cosine x. And that should be equal to f evaluated at c, which I don't know exactly what it is, but we will figure it out. So let's just leave it as this. So this is 4 times cosine c. And times the difference between the end points, so it's pi over 3 minus pi over 3. Okay? And it turns out that this is equal to 4 cosine c times 2 pi over 3. All right? So let's check the left-hand side. So if we know the antiderivative of 4 cosine x, we can use the fundamental theorem of calculus to evaluate this definite integral. So then you should ask yourself, whose derivative is 4 cosine x? And you can check the derivatives and integrals formula card provided in the beginning of the module. We can immediately find that 4 cosine x is the antiderivative of 4 sine x. So why don't we just write it here? So the antiderivative of that is 4 sine x, and I'm going to use the notation that we adopted in this section, so bracket notation. So it's minus pi over 3 to pi over 3, and that has to be equal to 4 times cosine c times 2 pi over 3. And this notation means that we're going to evaluate the antiderivative at the upper limit and the lower limit and subtract them. So this means that I have 4 times sine pi over 3 minus 4 times sine minus pi over 3. And that should be equal to 4 cosine c 2 pi over 3. And you can go ahead and use your calculators, but before doing that, you may also cancel out 4s. You can divide both sides of the equation by 4, so you don't need to carry forward that multiple 4 along the way. So if you use your calculator, or if you check the unit circle to find the exact value of sine pi over 3 and sine minus pi over 3, so you end up having just radical 3, because this is radical 3 over 2. This is minus radical 3 over 2. So if you subtract them, you have radical 3. So that's equal to cosine c times 2 pi over 3. And remember that we're trying to find c coming out of the statement of the mean value theorem. So we're going to leave cosine c by itself by multiplying both sides by 3 over 2 pi. Okay, so cosine c becomes 3 radical 3 divided by 2 pi. From pre-calculus, we know that c can be solved out of this trig equation. C equals cosine inverse of 3 root 3 divided by 2 pi. And go ahead and use your calculator to find an approximate value for this expression here. And we can perfectly go ahead and write f of c that is also 6 root 3 divided by pi. All right, it's time for analyzing the mean value theorem for integrals geometrically. So we have the function f for cosine x, and then the blue curve represents that. And we have y equals 6 radical 3 divided by pi, which was in fact f of c that we came up in a few seconds ago. All right. So as you see that the integral from negative pi over 3 to pi over 3 of 4 cosine x dx is the area, the orange area, right? The orange area between the blue curve and the x-axis. And the mean value theorem says that there's going to be a value c for which f of c multiplying b minus a, which is in fact the difference between two endpoints, would essentially be the same area. So in other words, this orange area here, which is the area under the blue curve and the x-axis, is exactly equal to the area of the rectangle whose one side has the length b minus a, which is essentially this side here. And the other side, the height of the rectangle, in other words, is in fact determined by this f of c, which is found to be 6 radical 3 divided by pi. All right, this is the end of the video. Thanks for watching. If you have any questions or comments, put down the video, and I'll see you in another video. Bye.